It's been a long road.
In our experiment, we decided to investigate the effects on the level of CO2 concentration on the rate of photosynthesis. Our hypothesis was that the rate of photosynthesis would increase with increasing CO2 concentration, since CO2 is a necessary reactant in the photosynthesis reaction. We set up our experiment with 4 different solutions, each with 1, 5, 10, or 20 grams of baking soda and 250 milliliters of distilled water, and 1 control group with only distilled water. The materials we used to conduct this investigation include different solutions of CO2, 10 discs of spinach leaves for any group, a hole puncher, syringes to remove gas from the leaves, diluted soap, and 2 lamps. Before conducting the experiment, we first removed gas from the leaves. This is a necessary procedure in order to get the leaves to sink initially, then to measure the rate of photosynthesis as they rise with the production of oxygen. What you see currently on the screen was our actual experimental setup. At the 4-minute mark, the 1, 10, and 20 solutions each had 1 disc floating. At 6 minutes, the 1 gram solution had 6 discs floating and the 10 gram had 2. The 20 gram solution still has only 1 disc floating, and both the control and 5 gram solutions have none. At the 8-minute mark, the 5 gram solution finally has a floating disc. The 1 gram solution adds another disc, making it a total of 6 leaves, while all the other groups remain constant. At the 10-minute mark, the 5 gram group has added another 2 leaves to the surface, and the 10 and 20 gram solutions each add 1 more floating disc. The control and 1 gram solution remain the same. 12 minutes have passed and all groups remain the same. By the 14-minute mark, all groups except the 10 gram group and the control group add a floating disc. There is no change until the 18-minute mark, when the 1 gram group and the 10 gram group each add 1 more floating disc. At the 20-minute mark, the final count reads 0 for the control group, 8 for the 1 gram, 4 for the 5 gram, 5 for the 10 gram, and 4 for the 20 gram. You will soon see in the 10 gram beaker that a green leaf circle will start to rise. That is because it is conducting photosynthesis and producing oxygen, thus making it buoyant and allowing it to float. Conclusions. According to our hypothesis, the number of floating discs should have been highest for the 20 gram solution. However, the data clearly shows that this hypothesis was wrong. The complete lack of floating discs in the control group suggests that some CO2 is necessary for photosynthesis. It seems, however, that too much baking soda can slow the process. The 1 gram solution showed the highest rate of photosynthesis. Not only did more discs float to the surface, the number of floating discs increased rapidly compared to the other solutions. The similarity of the rate of photosynthesis in the 5, 10, and 20 gram solutions may be due to H2O, which is another reactant becoming a limiting reagent. Their lower rate compared to the 1 gram solution may be due to excess Na+ in the solution that is generated from the baking soda, which is essentially sodium bicarbonate. The ions may interfere with the collision of H2O and CO2. Sources of error include droplets of solution spilled while removing gas from the leaves using syringes, the slightly wilted condition of the spinach leaves, and small differences in the position of the light source. This experiment could have been improved if all the spinach leaves were in healthy condition and the observation was extended over a longer period of time. This was our experiment, and have a good day.